Here in this question, a B plus tree is given and size of disk block is given as 8 KB. So disk block size nothing but 8 KB. Size of disk block is 8 KB. Size of the search key is given as 64 bytes. And disk pointer size is given as 16 bytes. 16 bytes. And it is given that file contains 10 power 5 search keys. Here we have to find the number of nodes to be accessed from the disk, assuming that root node is already in buffer. For lookup in B plus tree, we traverse from root node to some leaf node, and if there are k search values in the file, then the maximum length of the path is log n by 2, log k to the base n by 2, where n is the number of pointers. We can write n into 16 plus n minus 1 into 64 is equal to a complete node disk block size. This node should be stored in disk block. So which is of size 10 KB. So 8 into which is of size 8 KB. So 8 into 1024 bytes. So if we solve this, we'll be getting n value as 103.2. So here number of search keys is given as k 10 power 5. So the maximum length would be so here maximum path would be log n by 2, that is 103.2 by 2 ceiling function k is nothing but 10 power 5. This is ceiling function. So if we solve this, you will be getting 3. So we have to access 3 nodes, but it is given that root is already in buffer. So we have to access 2 nodes. So here the correct option is option A. In this question, a schedule is given and that schedule consists of 2 transactions T1 and T2, and the initial values of accounts X and Y are given as 100 rupees and 200 rupees respectively. And it is given that T1 and T2 are executed in 3 different ways. The first way is they are executed as given in the according to the given schedule, and in the second way T1 is executed, then T2 is executed, and in the third way T2 is first executed, then after that T1 is executed. By considering these data, we have to choose one of the correct options from 4 given options. If we execute transactions T1 and T2 according to the given schedule, we'll be getting X and Y values as, like, X and Y are given as 100 rupees and 200 rupees respectively. So here transaction reads X, data item X, account X, and X, from that 40 is subtracted. So value of X will be 60. After that X is written. So here 60 is written. Then here, and then transaction T2 reads account Y and 2 is subtracted from that. So here from 200 20 is subtracted, then 180 is written. After that transaction T1 reads Y and 40 is added to that. So here 180 will become 220 and 220 is written. Then transaction T2 reads X and to account X 20 rupees is added. So here 60 will become 80. So here 80 is written. So if we execute transactions T1 and T2 according to the given schedule, the final values of X and Y are 80 and 220 respectively. So if we execute transaction T1 and then transaction T2, what will be the X and Y values? So let us see this second way. So if we execute, so here the first initial values are 100 and 200. So let us execute transaction T1 first. So here first X from X 40 is subtracted. So here 100 will become 60, and then here y will to y 40 is added. So here 200 will become 240, and then we have to execute transaction T2. So if we execute transaction T2 will read y and 20 is subtracted from that. So here 240 will become 220, and then it will read account X and 20 is added. So here 60 will become 80. So after executing as given in the second way, that is as serial schedule T1, T2, then the final values of X and Y are 80 and 220, same as the first way, that is when they are executed according to the given schedule. So let us take the third way, that is T2 and then T1. So here initial values of X and Y are 100 and 200. So here first we have to execute transaction T2. So transaction T2 will read Y, that is 200. From that 200, 20 is subtracted. So it will become 180, and 180 is written. After that X from X, for X 20 is added. So 100 will become 20, and then we have to execute transaction T1. So transaction T1 reads X and 40 is subtracted. So here 120 will become 80, and then for Y 40 is added. So 180 will become 220. Here also the final values of X and Y are same as the earlier two cases. So here final values of X and Y are same in three given ways, but here the schedule is not conflict serializable. Why? Because here the given schedule is not conflict serializable. Why? Because the given schedule is not conflict equivalent with any of the serial schedule. We cannot obtain any of the possible serial schedules by swapping consecutive non-conflicting instructions. Even if we draw precedence graph with transactions T1 and T2, because of this write Y and read Y, there will be edge from T2 to T1, and because of this write X and read X, there will be edge from T1 to T2. So here in this precedence graph there is a loop between T1 and T2. So the given schedule is not conflict serializable. So here the correct option is option D. It says that final values of X and Y after 1, 2 and 3 are same, but the given schedule is not conflict equivalent with T1, T2 or T2, T1. So this is the correct option.